Right, I want to make sure, I know at the end of the last video I had to go kind of quickly. I'm assuming you understand why x is 2, because if we subtract 4.5 from each side, we get that x is 2. So that's 10 to the second, or 100 times as severe as on the Richter scale 4.5. So that 2-point difference is not 2 points, it's 10 to the second, or 100 times different. So that's just important to know as far as how the Richter scale works. All right, so now let's turn to our next page. We are not going to have time to do the graphing, so we are going to skip right to our practice. And my suggestion, if you're doing this on your own, is that you try to do some of these by yourself, and then maybe watch the video and see if you did it correctly. Right, so on this first one, I'm going to rewrite. I always rewrite exponentially, and then I solve. It's kind of my method. If needed, write with a common base. It's just some advice from me to you as far as kind of how you need to think through it. So I'm going to say 8 to the x equals 64. Well, I know 8 squared is 64, so x is 2. Let's go number 2. Equals x, so 7 to the x equals 7. Well, that one's pretty easy for me. X is simply x to the first. 7 to the first is 7. Let's go to number 3. Equals x, so 6 to the x equals 6. Well, 6 to the first is 6, so x is 1 again. Let's go to number 4. Equals x. 5 to the x equals 1. Remember, anything to the 0 power is 1. X is 0. Okay, equals x, so 4 to the x equals 1/4. Well, I need to move that 4 up into the numerator, so 4 to the x equals 4. Because I'm crossing the line, it becomes a -1. And as you can see, these have the same base, so simply x equals -1. Right, let's go to number 6. Equals x, so 3 to the x equals 1/9. So 3 to the x, I'm going to move that 9 up into the numerator, 9 to the -1st. I'm going to write this as with a base of 3. So let's come over to here. 3 to the x equals 3 squared to the -1. And so 3 to the x equals, remember, power to a power, we multiply. So 3 to the -2. These have the same base. Therefore, x equals -2. Okay. Alright, let's continue on. Let's look at number 9. If the log of k, remember that would be a 10, is 3.456, then k must be between which of the following numbers? Well, I always rewrite my log exponentially. I still always rewrite exponentially. So 10 to the 3.456 equals k. Well, this is between 10 to the 3rd and 10 to the 4th. 10 to the 3rd and then 10 to the 4th would be bigger than 3.456. 10 to the 3rd would be smaller. So it's somewhere between that. So it's somewhere between a 1 with 3 zeros and a 1 with 4 zeros. So somewhere between 1,000 and 10,000, which which is choice D. All right, let's go to 10 and 11. It says in 10 and 11, write an equation equivalent to the given equation using logarithms. All right, so now it's written exponentially, and we need to write it logarithmically. So it's log to the base is 4. Remember, the answer to the log is the exponent, and the answer to the exponential equation goes here. 4 to the 5th is 1024. The base goes here, the exponent goes here, the answer goes here. Let's try this one. Log, the base is 5, the exponent is p, and this answer, q, goes there. Right now in 12 and 13, they give us the logarithm and they ask us to write it exponentially. So 3 to the 7th equals 2,187. 9 to the n equals m. So remember, the answer to the logarithm is the exponent. This right here is the answer to the exponential equation, which is why the 1024 went here. It's why the q went here.